This is Chapter 1, Lesson 4. We did skip Lesson 3. We will come back and do that lesson at a later time in the school year. And this lesson is called Proportional and Non-Proportional Relationships. You should be familiar with both of these words from previous years, but we're really going to hone in on what makes a relationship proportional and non-proportional in this lesson. So let's start with some vocab. Remember to keep your vocab caught up in those flashcards and study them every night. First set of vocab words is equivalent ratios. Equivalent ratios are two ratios that are equal when simplified. Okay, we did that a little bit in Chapter 1, Lesson 0 when we saw if those ratio examples were equivalent. Proportional, big word for this chapter, big word for this chapter. A proportional relationship is a relationship in which all the ratios are equivalent. Okay, so if a relationship is proportional, then all of the ratios will be equivalent. So if we take all the ratios and we simplify, or if we turn them all into unit rates, we will see that they're all equivalent. Non-proportional is a relationship in which the ratios are not equivalent. Okay, so obviously proportional and non-proportional are opposites or antonyms. So let's see an example of how to identify relationships that are proportional or non-proportional. So this is the example in your notes, and this is a long one. If you keep following along with me, I'm going to keep going down this slide, but this takes up almost an entire page in your notes. So please follow along. This is really some good math here. Our first example says, Mrs. Shuck is planning a year-end pizza party for her students. Stuglia's Pizza offers free delivery and charges $9 per medium pizza. So, first thing we're going to do is we are going to complete the table. Free delivery is a big important thing here, so that means all that we're paying for is the pizza, nothing else. So if we pay for one pizza, we will spend $9. Two pizzas, 9 plus 9, is $18. Three pizzas, 9 plus 9 plus 9, or 9 times 3, is $27. Four pizzas is $36, and 5 pizzas is $45. Okay, so there's our first step, is to get our table. A lot of the work in this lesson will be with a table. So now what we have to do is take each one of these relationships within the table, and we have to find the unit price. Okay, so remember, money in the top, time in the bottom, or in this case, money in the top, pizza's in the bottom. So my first relationship here is $9 per one pizza. Lucky for us, that's already a unit rate, so we can move on to the next relationship, which is $18 for two pizzas. $18 for two pizzas. We are going to divide by 2 to make that a unit rate. And we get $9 per pizza. So far, our relationships, our ratios, our unit rates are all the same. But we have to keep going to prove that they're all equivalent. So the next one is $27 for 3 pizzas. To turn that into a unit rate, we will divide by 3. I'm not going to show that work because it takes a while. I'm trying to make the video short for you guys, so I'll just show our unit rate, which is $9 per one pizza. So far, looking good, but we have 2 more to test yet. $36 for 4 pizzas. $36 for 4 pizzas. I would divide the numerator and denominator by 4, and I'd get $9 for one pizza. Last ratio in our table is $45 for 5 pizzas. And I would divide the numerator and denominator both by 5, and I would get $9 for one pizza. Take a look at those ratios. $9 per pizza, $9 per pizza, $9 per pizza, $9 per pizza, $9 per pizza. Since each one of those relationships, each one of those unit rates is equal to $9 per pizza, that's question C here. What do you notice about the unit prices of the different amounts of pizza? They are all the same. And that's really important to this problem. unit prices are all equal to $9 for one pizza. What does this tell you about the relationship? That's our indicator that this is a proportional relationship. So let's hop back to our definition really quickly. A proportional relationship is a relationship in which all the ratios are equivalent. All right? So we went and we checked out every single relationship in the table. And we did the unit rates for every single relationship in the table. And they all came out to be exactly the same. So because they're all exactly the same, we can say that this is a proportional relationship. And we say it in a special way. We say the cost is proportional to the number of pizzas purchased. So, yes, this is a proportional relationship. The money is proportional to the pizzas. That's pretty much what we're saying. And the reason for that is because all of the unit prices were the same. Okay? If you need to pause the video to get caught up on any of that, please do so. If not, let's skip to the next example. Example number 2. Mr. Shuck is also planning a pizza party for his class. He orders pizza from Domino's. Domino's charges $7.50 for a medium pizza. So it's a little bit cheaper than Soglia's, but they include a $3 delivery fee. Is the cost proportional to the number of pizzas purchased? Well, the first thing we have to do is understand the delivery fee. $3 is a delivery fee, which means it doesn't matter if you order 1 pizza or 20 pizzas, they're going to charge you $3 to deliver it because they determine the cost of the person getting in their car and driving it to your house is $3. So keep that in mind as we fill out our table here. If we buy 1 pizza, we will pay $3 delivery fee plus the cost of the pizza. So $7.50 plus the $3 delivery fee is $10.50. If we buy 2 pizzas, we're going to pay the cost of 2 pizzas plus the $3 delivery fee. So $7.50 plus $7.50 is $15 plus $3 delivery fee is $18. Notice that delivery fee is not added for each pizza. It's only added 1 time because they're determining that's the cost of taking the pizza to your house. 3 pizzas. 3 pizzas would be $22.50 plus a $3 fee. That's $25.50. And 4 pizzas would be $30 plus a $3 fee, which is $33. Okay, so there's our table. Now we are asked if the cost is proportional to the number of pizzas purchased. So our second step, remember our previous problem, first we made the table, then we found all the unit prices. So we need to find all of our unit prices here. The first price is $10.50 for 1 pizza. Lucky for us, that's already a unit rate or a unit price, so we can move on to the next one. The next one is $18 for 2 pizzas. And if we want to turn this into a unit rate, we have to divide both the top and the bottom by 2. And when we do that, we get $9 per pizza. And what we can do now is we can actually stop. This problem's over. It's finished. I have my answer. I can tell that this is not a proportional relationship because my unit prices are not the same. Notice it took a lot more work to prove a relationship is proportional. I had to prove that each of these relationships equaled the same unit rate. But as soon as I found 2 that are not equal, I can stop and I can say, nope, this is not a proportional relationship. The unit rates are not the same. So that's exactly what I'm going to write. This is not a proportional relationship because the unit rates are not the same. And that's it. It's much easier to prove that a relationship is not proportional than it is to prove that a relationship is proportional, because we have to show every single unit price is the same to make it proportional. But as soon as you find two that are not equal, like we had here in example 2, you can stop and say, well, we're good. Not proportional. The unit rates are not the same. Okay? So in this lesson, you're going to notice you're building a lot of tables. Pay attention to the wording of the problems. You have to understand things like a delivery fee. Okay? You can go ahead and complete these problems in your practice problems. Ask any questions in class tomorrow, and please, please, please keep caught up on your flashcards.